my name is Pedro Sanchez. Today I'm going to talk about my smart Bluetooth gateway project. So let's take a deep dive into the project. I will show you everything about it. Hello and welcome to this project. It's a smart Bluetooth gateway done to be able to track down different beacons, which are Bluetooth devices. The way in which I track them down is by looking at the advertisement information. There are several types of beacons, as you can see. There is beacons that publish temperature, beacons that can publish movement acceleration in X, Y, and Z, beacons that can publish also vibration movement. There are waterproof beacons, beacons for alarms, beacons to find devices, beacons to track assets, etc. Due to the recent deployment of a lot of devices using Bluetooth BLE, there is a need to track them, especially in applications where they can be used for asset tracking. That's one application. Another one is to track, it could be people in hospitals or with a health condition, that when they are nearby any gateway and they have any condition, that can be transmitted. So what I did is I'm working with an argon. The argon is made by particle, and what I'm doing is that I am making proof that with an argon I can monitor dozens of devices. I can track where they are. I can publish to a dashboard. I can also send push notifications to smartphones. I can also publish and detect if a given beacon has stopped advertisement of data. I can also detect if a beacon has come back into normal mode. And the way I have done this, I'm using beacons by a company called Minu, and looking at their UUIDs, which is like the equivalent of their serial numbers or MAC addresses, I can easily detect which beacons I'm going to be tracking. So I have a learning mode, which is implemented with a push button. I also have a GPS, so I can display the GPS location. My screen, due to the hertz and resolution, is, if I zoom out, it doesn't look good, but when I zoom in, I can look at it. Right now, it is in normal mode, as you can see. It displays the time, the total number of beacons. Right now there is 0. The ones that are in alarm, right now there is no alarm. It displays also if there is any beacons that have lost signal, maybe lost signal meaning that I cannot reach them. They have stopped advertisement, maybe because the beacon was stolen or the asset was stolen, maybe because the battery went dead, even though most beacons average battery life is between 2 and 3 years. That depends on the power level. Or it might be the case that they're moving and they move far and they're going to come back. But anyways, if that happens, I immediately send a notification. I update the dashboards. I'm using Adafruit dashboard. I'm also publishing to Particle.io and invoking a webhook to send a web post to a service called pushover, which will immediately send a custom message. I take fields from the JSON data that I send to Particle, and that it is transmitted automatically to pushover with the webhook. So I send a customized message letting the user know if the beacon has gone out of range, if the beacon came back, if the beacon just registered, or if the beacon is lost for a certain time. So how do I do this? Well, I'm just doing it with one particle argon. I don't have to do many boxes, and I use RSSI, and after looking at and doing some research on RSSI and radio frequencies, I came to the conclusion that with one box, actually, I can track a lot of devices, but if I wanted to track more devices, I'll need maybe 4 or 5 boxes so that I can do triangulation or quadrillation, if that word exists. The more I have, the more I can look at the distance from between and know where they're moving. Like I can have them 90 degrees angles separated from where I'm going to be monitoring. So I'm going to start the system into learning mode. Just pushing this button here. I push this button, and the system goes into learning mode. Immediately I can see that I have one device registered. So the devices are configured. They come with a utility where I can configure how many time slots I can use to advertise data. So I can advertise at different time slots. Right now, what I'm going to do is I went into learning mode, and I have one device right now. So as the devices are coming, I publish, but I don't publish right away. I wait pretty fixed number of seconds because I don't want to take all the time doing that. So I'm publishing every 30 seconds. So I see 4 of them there. I'm going to stop now the normal mode. So I mean the learning mode, sorry. I just stopped the learning mode and I went into normal mode. Last time I had found 5 beacons. So 5 beacons were found last time. Now I'm going to see how I'm going to show how all of this is implemented and why I took the design decisions to do that. Right now, so I can see here, I haven't taken one far away, but if I do so, I'll start to see alarms, and with that, let's see how this is done. Every time more and more BLT gateways are used to monitor devices. For once, they offer a lot of battery life and they're very reliable. They can operate for long times and they can report information. For example, see this dashboard where I report the information on the devices. We see the devices that have been registered, any device that has gone into alarm, and any device that is not advertising it. That gives a lot of help. I also notify of events, the relative with events with sensitive information when a device is registered, when it is lost, when it is advertising again. Also, if it goes out of range. So there is a lot of information for the user. Now, to implement this, I had to use different technologies. Over here is a webhook posting which gets the information as I publish in code, and that information is the one that is sent to the user. I also have a screen in the device where I show information with latitude, longitude, and all of the different scenarios for devices. In code, I can show the data structure here, which is interesting and important because I have an array of devices with a structure with all the relevant fields and an array of timers. That way, this solution can scale to an amount of devices, which is really great. I also here show a fragment of the code where I, based upon different information, develop an algorithm to find out if a device is lost and reported in a JSON format. I also have another separate algorithm to register new devices. Make sure that no device is left when in learning mode, which I should talk about at the beginning. This is the casing that I used for my project, and it was really a lot of fun to do it. And I show the components when I started the video of the project. In conclusion, I learned a lot. RSSI is not as simple. You have to do your own algorithm and you have to have several devices. I'm looking forward to do that, continue doing that, and also to use angle of arrival, the new technology for asset tracking. Thank you.